The time T required to do a job varies inversely with the number of people P working on the job. So first we're going to write this as an equation. So the time T, so T, varies, so we're going to say it varies inversely with the number of people working on the job. So if it's an inverse variation, it's going to be the constant on the top and then the other variable on the bottom. So T equals K over P. T varies inversely with the number of people. So once we have this set up, we're going to fill in what we know. So take 6 hours for 8 workers to complete a job. So we're going to solve for K. So K equals TP. And we know that the time is 6 hours and the number of people is 8. So K equals 48. So our constant is 48. So our function is going to be T equals 48 over P. That's the function that models it. So how long will it take if there are 9 workers? So we're going to solve for T, and we're going to plug in 9 for P. So 48 over P. So this is going to be about 5.3 hours. Okay, so you're setting up the equation, you're solving for K. Once you know what K is, you're writing your function, and then you're plugging in your information. The loudness L of sound measured in decibels, dB, is inversely proportional to the square of the distance d in feet from the sound source. So let's write the basic equation here for this. So the loudness L, so that's what we're going to have it equal to. So L equals, since it's inversely proportional, we're going to have K on the top, and it's inversely proportional to the square of the distance d. So that's d squared. So if we solve this for K, K is equal to L d squared. So we can plug in what we know. So K equals, if a person is 15 feet from a leaf blower, the sound is 100 decibels. So L is going to be 100. And then the D that we have is 15. And then we're going to square 15. So K is going to be equal to 22,500. So now that we know what K is, we're going to write our function. So L equals 22,500 over D squared. So how loud is a leaf blower if someone is 45 feet away? So the distance is 45, and we're solving for L. So L equals 22,500 divided by D squared. And it says round to the nearest hundredth. So L equals 11.1 decibels.